These are the Geometry 7.1 video notes, part 1. We're going to cover the prereq skills practice question in examples 1, 2, and 3 today. Okay, on this prereq skills practice, they say find the value of x. X is this exterior angle right here. Now they show us a triangle, and we know that a triangle has 180 degrees. Now we know this is an equilateral triangle because of these three congruence markings right here showing us that all three sides are equal. Now remember, on an equilateral triangle, if all three sides are equal, then all three angles are equal. So if a triangle equals 180 degrees and you divide it into three equal angles, that's 60 degrees each. Okay, so now knowing that, x degrees and 60 degrees together create a linear pair. They form a line together, meaning that they are supplementary. And supplementary means they add up and equal 180 degrees. So the angle that is x plus the 60-degree angle equals 180 degrees. So you can subtract 60 and you find out that x equals 120 degrees. Now the reason you see me only put 120 and not put the degree symbol is because I already see this degree symbol up by x. So by putting 120, I already know that it is in degrees. But I don't think it's a problem if you also put the degree symbol. All right, two vertices that are endpoints on the same side are called consecutive vertices. So for example, on this image shown below, A and B are consecutive vertices. They form the endpoints of the side AB. So when you connect two non-consecutive vertices, so for example, like B and D, they are non-consecutive vertices. When you connect them, it creates this line that goes across the shape, and that is called a diagonal. So a diagonal of a polygon is a line segment that is formed by connecting two non-consecutive vertices. And remember, consecutive means just in a row. So consecutive means they come right after each other and they form the two endpoints of a side. Non-consecutive means when you connect them, instead of creating a side, you created a diagonal. All right, so today we're learning the polygon interior angles theorem. This is the polygon interior angles theorem right here. This n minus 2 in parentheses times 180 degrees. What this formula says, or what it finds you, I guess, is it finds you the sum of the interior angles, interior means inside, of a polygon with n sides. So I'm going to call that an n-gon. So it must be a convex n-gon. It cannot be concave. Remember, concave is where if you do draw a diagonal, it can go outside of the shape. It's like this case in. So this right here is a concave shape. So this formula does not work for concave shapes. It must be convex shapes. And n is how many sides there are. And so if you know the number of sides, you just plug that into the formula for this n. And it's parentheses n minus 2 times 180. And that gives you the sum of the interior angles. So this comes in handy a lot in geometry. This question says, find the sum of the measures of the interior angles of the figure. So the first thing you do is figure out how many sides. So I'm going to start here. This says 1, 2, 3, 4, 5, 6, 7, 8. So this has 8 sides. So that means n is 8. So to find the sum of the interior angles, you do n minus 2 times 180, which 8 minus 2 is going to be 6. And then you're going to do 6 times 180, which if you type into a calculator is 1080 degrees. And remember, this is finding the sum of the interior angles, not a single interior angle, but the sum of interior angles. All right, so on this figure, you count the sides. I just kind of mark which side I'm starting with so I don't lose track. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. So n equals 10. It's a 10-sided figure. So we're going to do 10 minus 2 times 180, and that's 8 times 180. And you can type that in your calculator. and you get 1,440 degrees. And remember, that's not a single angle. That's what all the interior angles add up to. That is the sum of the interior angles of this 10-sided figure. All right, example 2 is going to use the same formula, but it's actually working out, it's asking us to work backwards. It says the sum of the measures of the interior angles of a convex polygon is 900 degrees. So they're telling us the sum of the angles. Classify the polygon by the number of sides. So basically, we don't know the number of sides, so that means we do not know n. All right. So we set up our equation since we don't know n, but we do know the sum is 900. We put our equation equal to 900. Now we solve for n. So first, I'm going to divide both sides by 180. And so I'm still left with n minus 2. When I do 900 divided by 180, I get 5. So then I add 2, and I get n equals 7. So it has 7 sides. And the name for a 7-sided figure is a heptagon. All right, so let's try this again. The sum of the measures of the interior angles of a convex polygon is 1,800 degrees. So we don't know how many sides. That's what we're trying to find. So we take our formula, and we don't know n because we don't know the number of sides. We set it equal to 1,800. So now, once again, we divide by 180, trying to get n by itself. So I get 1,000, or I'm sorry, I get 10. And then I add 2, and I get n equals 12. So if n equals 12, then it has 12 sides. And the name of a 12-sided figure is a dodecagon. Now, this formula works for any convex polygon when you're looking for the sum of the interior angles. That being said, sometimes it's just easier to know some things. So like we know that the angles inside a triangle add up to 180 degrees. So the angles inside a quadrilateral, keep in mind a quadrilateral is a 4-sided figure. So if it's a 4-sided figure, the sum of the angles is 360. Now it would be really nice just to know that, so we don't continually have to use this formula, which we could use at any time. But since we're going to see quadrilaterals a lot, it's just nice to know that all the interior angles of any 4-sided figure, a quadrilateral, add up to 360 degrees. So you can see on this one right here, this is a quadrilateral. There's 4 sides to the shape. They want us to find x. X is one of the interior angles. So if you add up all 4 angles, they should equal 360 degrees. So now I'm going to go in my calculator right here and add up these 3. So that makes 288. I still have the x. So to find out what x equals is, I subtract the 288 from both sides, and I get 72. And once again, I don't have to write degrees because you see there's already a degree symbol right here. So if I write 72, it's understood that that is representing degrees, but you could put the degree sign and I'm sure it would be okay. All right, if you look at this shape, think about how many sides it has. So it has 6 sides. I don't necessarily know what a 6-sided figure is in terms of how many degrees it has. So if I use that formula, 6 minus 2 times 180, that's going to be 4 times 180, which is 720 degrees. That's not what one angle equals, but that's what all the angles added together equal. So if I add up all 6 angles, x is one of the angles, then it equals 720 degrees. Now, in my calculator, I can add up this 118, 111, 124, 115, and 145 in my calculator. That makes 613. And then to get x by itself, I subtract 613 from both sides, and I get 107.